Hi everybody, we are going through this question from 2010, a 10-year series question involving mole concept. So let's look at the question itself. So we have an alcohol, right? CXHYOH. So we are told there is a fungal metabolite, whatever that is. It can indicate hidden fungal attack on timbers of a house. Okay, so the first piece of real information is coming when 0.1 cm cube of liquid J. So this is like a combustion question. As you read on, you realize that yeah, it is a combustion question. But most combustion question, right? Your hydrocarbon usually your organic compound, right? Usually is not a liquid. Usually is a gas. Okay, but for this question is very special. What they're given to you is a liquid. Okay, so to approach this question, we cannot use the Avogadro's law to use mole ratio equals to volume ratio. All right, so we can't get the number of moles from the volume ratio. Okay, let's read on. It's dissolved in an inert solvent and an excess of sodium metal added. So you have alcohol reacting with sodium metal. Okay, so if you have done your organic chem, you will realize that alcohol will react with sodium metal to give hydrogen gas. But even if you didn't know that, the question goes on to tell you 10.9 cm cube of your hydrogen gas is produced. Alright, so this is produced at RTP. So this condition, you need to know there is RTP. Molar volume is 24 dm cube. Okay, this was produced according to the following equation. Okay, so very nicely they have given to you acid metal reaction so that you don't have to balance it yourself. Okay, so what is this whole first part for, right? This whole first part is basically for you to use 10.9 to calculate the number of moles, okay? Number of moles of hydrogen gas. Okay, so once you have calculated the number of moles of hydrogen gas, means that you have calculated this thing over here. You're going to use the mole ratio here, 1/2 to extrapolate what is the number of moles of your alcohol. So once you calculated number of moles of hydrogen, you can then use it to calculate number of moles of your alcohol J. Alright, so instead of using the volume, right, we make use of this volume of hydrogen, not the volume of the liquid J itself. Okay, let's look on at the second part. Excuse me. So again, you have the same volume, same amount of liquid J, your alcohol, combusted in an excess of oxygen. The volume of the gas, again measured at RTP, was reduced by 54.4 cm cube. Now this you got to be really very careful. After you combusted, right, you've used up a amount of oxygen. So let's take it like this amount of oxygen, right? You're totally used up, but you have also at the same time produced a certain amount of CO2. Okay, so what this question is really saying is that while you have used up this big amount of oxygen, right, you have to net off the effect with the CO2 that was produced. Okay, so if let's say, for example, right, you've used up, let's say, I'm not saying for this question, let's say you used up 100 cm cube of O2, right? But if you produce 60 cm cube of CO2, what you're going to see net, right, is that the volume of the vessel, the volume in the enclosed vessel is going to decrease only by 40, okay, because you net off the 60 cm cube. Okay, so even though there's a decrease in 100 cm cube of oxygen, 60 cm cube of carbon dioxide was produced. So net you only see 40 cm cube decrease in your enclosed vessel. Okay, so that's what they are saying about this 54.4 cm cube. Okay, let me erase off my drawings here. Okay, after you've understood this, right, that 54.4 is a net result of the decrease. Okay, write it down, the decrease of reacted oxygen plus the increase of CO2 produced. Okay, the net result. Then after that, they say that after you pass this gas through a base NaOH, you decrease the volume by 109. So again, it's at RTP. So we noted that this 109, right, is probably the acidic CO2 that was absorbed. Okay, CO2 is acidic and is absorbed by the NaOH. So this is very useful in our calculation because once you understand that CO2 is 109, right? So in order to find, like, remember earlier on we did this diagram, right? Okay, hold on. We did this diagram O2, and then we are only told about the 54.4 cm cube. Okay, because the rest had been negated by CO2 produced. Okay, got it? So you got this amount of CO2, which we now know to be 109 cm cube. Okay, so if this is 109 cm cube, how much is this volume of O2 that was initially used up? We simply have to add 109 plus 54.4. Okay, that will be the amount of reacted O2. Okay, so putting all this that we found together, right, then we are able to work out the X and Y very easily. All right, so calculate number of moles of H2. Okay, that will give us 4.54 times 10 to the power minus 4 moles. And then we also calculate the number of moles of your alcohol, which we just need to multiply by 2 because of the mole ratio. Okay, so we got the number of moles of your alcohol already. And then we'll just take the volume of CO2, 109, divided by 24,000. So this again is our number of moles of CO2. Okay, so to find what is X, right, you just use the mole ratio. Okay, put one over the other. Then you will find that X is equals to 5. Okay, actually this should be X over 1 because this is the mole ratio from equation. Okay, from our balance equation. Then this part here is the actual number of moles that we found through all these volumes, right? So the equation number of moles, it should be the same as the actual number of moles found in your volumes, calculated by your volumes, right? So once we got X equal to 5, then we're going to make use of the second piece of information, which is the volume of reacted oxygen. Okay, so we found it to be 6.81 times 10 to the power minus 3. Okay, then once again, we are going to put the actual number of moles as a fraction on the right side. The left side is basically the coefficient over 1. Alright. Then you'll find that this is equals to 7.5. Solving for y. Make sure you substitute your x equals to 5 and you got y as 11. Alright, so guys, let me know any question you have. just put it in the comments and I'll try to reply you. Hope this video has been useful. Remember, this is a very common question. I think it is in all our schools tutorials, okay, for Mo concept. Very important question.